Okay, our next session we're going to start with is on tableland legumes, and we've just got the two speakers in this session, Jeff Lewin and Carol Harris. To start with, Jeff is going to give us an overview of the legumes that are suited to the tableland and the value of those legumes to livestock production. So Jeff is with LLS, the Northern Tablelands LLS, and I think he's had a bit of help from Mick Duncan in pulling this together. So I will pass over to you, Jeff. Thanks a lot.
Okay, thank you very much, Warwick, for that. And yes, you're right, Mick Duncan, the private agronomist based in Armidale, helped me to put this together. Next slide, please. Okay, thanks. Obviously, we're talking about the temperate high rainfall zone, and for most people that will refer to the Northern Tablelands. So we are looking at the legume options that we use on the tablelands, and as you can see a list there, they're the main legumes that we look at for the tablelands. Obviously, white clover is the major one that we use. And a lot of the white clovers that you'll see here are the small leaf types, and they seem to persist better under grazing. Obviously, people that are sowing white clover use what we used to call the New Zealand white or Racehuria, but keep in mind that there are a lot of eco types that actually come back, or white clover that has become naturalised over the years. Subclover is another clover that we look at. Not a lot of people use it because over the years they found that it doesn't come back that well. Some people thought it was because of the lack of heartseedness in the subclovers, but in actual fact researchers found that it's more the grazing management that is the issue. If we can graze our pastures down reasonably short, but not too short, obviously, during that late summer, early autumn, then we will get plenty of subclover. But obviously for the Northern Tablelands, that sort of management system doesn't suit the whole property, because part of our techniques here of getting through the winter period is to build up the pastures during that autumn period. Red clover is another one that's used frequently in our pasture mixes here. Obviously, most people know that it's just a biennial. In other words, only lasts a couple of years, but many producers find that that it contributes to their pasture for a much longer period. Obviously, that depends on the management. If it's managed correctly, every year or so, the red clover will set seed. So to get the persistence out of it, it is the new plants that are coming back from the seed. Lucerne is also used on the tablelands, but it is limited where it's used by the soil type and also the pH of the soil, including aluminium. We do have some problems with disease, anthracnose, crown rot, things like that, pythium, also for the seedling. But if you have country where lucerne can grow, which is the heavier soil types, the basalt types, it's still considered to be the king of fodders, particularly for land production. Lotus, I've got mentioned there, the Lotus pedunculatus, or the marquee types. Yeah, in the past we've used that for the wet areas, and it grows very well in those wet, swampy areas. Next, please. The other options that people have actually looked at for the Northern Tablelands is strawberry clover, which is quite useful in damp areas, not quite as wet as the marquee lotus, but where it's reasonably damp, strawberry clover will grow quite well. Woolly pod veg is more on the western side of the range, on the sort of heavier soils. It's used there. Arrowleaf clover is another one, and Bicerella It's also used, as you can see there, it's used more on that western side and also on the shallower soils. Those last three that we mentioned obviously are annuals, and therefore they have to come back from seed each year. And again, points to the fact that grazing management over that late summer, early autumn period can be critical. Next, please. Some of the other options people have used on the tablelands here are the medics, particularly snail and Zephyr. Cerebella has also been tried, not really successful as such at this point in time, but maybe in the future there is some purpose for it. And the last one we've got there is the Lotus cuniculatus, or bird's foot trefoil. Goldie is the main variety that was about at the time. It showed a lot of promise, but hasn't really taken off, and that's probably because of the seed price at the time. Next, please. Okay, one of the things that we look at is the value of legumes to the livestock, and as you can see there, so legume value to the livestock is via two pathways, both in yield of the pasture and also in the quality of the pasture. Obviously, with legumes, you will increase the total pasture growth through the fixation of the nitrogen via nodulation. And as far as quality goes, adding the legumes in there will increase the quality based on the fact that the legume itself, but also with the nitrogen take up by the grass, that then increases the protein in the grasses. And as you can see in the diagram to the right there, the big difference between where you've got grass only and compared to white clover, the difference in the relative animal production is quite large there. So as you can see, legumes are very valuable to the pasture system on the tablelands. How important it is does depend on the enterprise that you're running. Obviously, if you've got a growing fattening type enterprise where the quality of the pasture is there, having that legume is very important. Whereas dry sheep cattle is still important, but not to the same degree as that for growing or fattening animals. Next slide, please. Issues facing legumes on the tablelands, obviously climate change, as most people know, will have a major effect on our temperate species. Obviously the climate is getting warmer, the rainfall patterns and also the intensity of the rainfall patterns are changing, and also there are changes in the frosting period. Data from the Met Bureau shows that frosts are actually starting later as well as finishing later. And so at this point in time, we're not sure what sort of impact that will have on legume production. Next, please. Those climate change effects will have a influence on both the growth patterns and also the germinations, particularly the annuals that have to come back each year. The climate changes could have an effect on the seeding ability and therefore impact on the soil seed bank. And this is probably mainly brought about either by dry periods at flowering and also the late frost. Persistence will also be influenced, particularly if you look at white clover. Although in theory white clover is a perennial, most of it, up to 80%, behaves as an annual on the tableland. So with climate change and things like that, whether it can keep coming back each year is yet to be seen. Next, please. So yeah, with the climate change, obviously what we need to look at is more perennial types of legumes, and also ones that have better dry tolerance. There was some work done in the past on white clover, as with varieties of trophy and tribute, to try and have better drought tolerance in the white clovers. I believe there's still a lot more work that needs to be done there. Next. Some of the other issues facing legumes is the livestock health issue, blood and pulpy kidney. Obviously with legumes, those health problems become a much bigger issue. Obviously vaccinations and things like that can help to reduce blood and pulpy kidney, but maybe there's some work that we can look at to breed legumes that helps to reduce blood. Some of that has been done in the past, but further work probably needs to be looked at. If you look at Lotus caniculatus or Goldie, there is some research work that showed that a small percentage of that in the diet helps to reduce blood. So obviously we need to look at some way of getting Lotus to be more adapted in the area. Next. Other issues is the soil fertility limitations. Obviously, a lot of the common legumes that we use on tablelands have a high phosphorus and sulfur demands. Fertilizers, as most producers know, are expensive, and also that fertilizer is a finite resource as well. So we need to look at maybe ways of trying to develop legumes that don't require such high PNS demands. Increased soil acidity leading to toxicity issues. On the tablelands here, aluminium, manganese and iron are probably the three main ones. Although most of our soil acidity on the tablelands is actually inherent rather than induced by our management system. Trace elements is another area as we looked at the plant uptake in relation to animal and also human health. There's things like that we've got the copper, cobalt, selenium, three that come to mind quickly. And the other one with the legume is legume seed viability. There is some thoughts there that our boron levels may not be sufficient to be able to create viable seed. The seed may form, but it's not actually viable. Now that issue is probably more on the eastern side of the tablelands rather than on the western side. Next. Legume nodulation, the question is, are plants fully nodulating at sowing? When it's sown directly in ground or aerial sowing, that's always been a question as to how effective those plants are nodulating. And as a regenerating seedlings as well, in other words, those plants that are coming back from seed each year, how effective is the nodulation on those plants. There's some work in the past that's been done by Belinda Hackney that looked at soil pH, and she's found that it needs to be greater than 5.5 to be a great benefit to the nodules. So maybe a bit more work needs to be looked at there. Disease and insects, at this point in time, there's a range of them, but we're not sure the full extent and the impact, particularly of the diseases. Next. Research and development. Yeah, we've touched on some of those, but obviously the main ones that we need to look at is increased persistence and production of legume base in pasture systems, keeping in mind climate change that's occurring, cost structures that producers are faced with, and also the changing markets. As I said before, the animal health issues, particularly bloat, more research and development probably needs to be done in that area as well. Next slide, please. One of the things on the tablelands in the past, it's been traditionally looked at as being suitable for the temperate pasture species, but with climate change, a lot of those temperate species, particularly on those shallower soils, are not persisting like they used to. So maybe we need to start looking at the economics of replacing temperate pasture species with the tropical grasses, but we also need to find suitable legumes that will go with the tropical pastures. And if we replace tropical grass species, obviously the quality of tropicals is not quite as good as the temperate, so we need to look at supplementary feeding protein to be able to get similar sort of production from those tropical grasses with the livestock. And we need to look at probably the more persistent tropical legumes under intensive grazing compared with extensive grazing, where they're grown at present. A lot of the tropical legumes that I've dealt with on the verge of the tableland under grazing do not persist very well. Next slide, please. And of course, keeping in mind that on the tablelands, greater than 70% of our pastures based on the native pastures. That's where our livestock production comes from. Obviously, a lot of those are the improved natives where we fertilised and as a spread clover seed out with that. And as people would know, native pastures are more adaptable to the climatic variations and also the lower soil fertility. So, you know, we probably need to think about whether the native species can be developed further than what they have been. There are probably some gains to be had to look at the native pastures, both the legumes and the grass ones. And I think that's it, is it? Is there another one, Lucy? Yep. No, that's it. Thank you very much, Warren.
Righto, thanks for that overview, Jeff. We've got a couple of minutes for questions, if anyone's got a question out there. Nothing coming through at the moment. Jeff, so just a quick question from me. How are you finding the legume regeneration after the really tough season you've had there on the Northern Tablelands? Are you getting, as an example, your white clovers coming back?
Yeah, Warwick, quite a lot of the white clover is coming back, but not to the same degree this year as it has in past years. There was some work that was done probably nearly 20 years ago that looked at the soil seed bank of white clover, and because that was back in the early 80s after the 80s drought, and the question coming from producers then was that white clover's not coming back. But that work found that there was quite a high soil seed bank, with a high percentage of hard seeds in it. So, given the right seasonal conditions, in other words, the rain at the right time in that early autumn period, yeah, white clover will actually come back reasonably well.
Yeah, okay, thanks for that. I think that's hopefully that occurs so we can get those pastures back up and going.
Yeah, well, true, but keep in mind that obviously the paperback producers also have to have the right soil fertility levels there as well. That does make a big difference where country has been regularly fertilised and the soil PNS are at critical levels. White paper regeneration is much better there.
Yeah, thanks, Jeff. That's great. Okay, we'll hand over now to Carol Harris, and she'll talk about increasing legume adaptation work. So Carol's a research scientist with the Department of Primary Industry. Thanks, Carol.
Thanks, Warwick, and thanks to the organising group for putting this webinar symposium together. Since I'm the last one on the cab, and I know it's getting close to lunchtime for all those people who've been on the long haul, also I'll try and be as quick as I possibly can. So I'm going to continue on from Jeff's talk on legumes, and there probably will be a little bit of overlap with some of the issues that are coming along, but bear with me if there's too much overlap. So today I'm going to talk about an LPP project called Extending the Boundaries of Legume Adaptation through Improved Soil Management, which is a bit of a mouthful, so from now on I'm just going to call it Extending the Boundaries. And so this program has been set up to address some of those challenges that Jeff nominated in his talk around soil fertility, climate, and other management issues. Once again, it's sort of really the target zone for this project is the high rainfall permanent pasture zone. So think the Great Dividing Range, high rainfall, usually high elevation or altitude, variable soils, but often characterised by acidity and low fertility, and also shallow soils. With pasture production often limited in winter due to low temperature and frost, and then in summer often limited by summer moisture stress. And in Jeff's talk, he sort of outlined a number of legume options that we have in this zone, and a number of them were annual. But this project is concentrating on temperate perennial legumes, so that we believe the benefits are that they give more stability to the pasture system. The more deeper and long-standing root system enables the legumes and the plants to access soil moisture and soil nutrients better. And it also probably provides a more consistent or even spread of feed over the growing season, and also is able to access make more nitrogen over the year. So I might go to the next slide, please, Lucy. Yeah, what have we done? So the importance of legumes was also covered by Jeff in the presentation. And so obviously that they drive pasture reduction and nitrogen fixation, and there's an added benefit of pasture quality aspects for the animals. Jeff also talked about the predictions for changing climates and highly variable seasonal conditions. And it's usually the legumes in our pasture systems that are most vulnerable to these variable climate conditions that we encounter, and particularly moisture stress and increasing high temperature. So we really need to address how we can improve the consistency and reliability and the consistency of feed from year to year, not only within a year, of the legumes, and how we can improve the drought sensitive perennial legume species that we currently work with. Next slide, please, Lucy. So this is the objectives for the Extending the Boundaries project. I won't go through them in a lot of detail, but basically we aim to produce some management packages at the end of the project that are all around how we can improve the productivity and persistence of temperate perennial legumes. And we're doing this by collecting some objective data, defining the productivity range of some legumes and the mechanisms that are used to drive persistence. We're looking at the impact of changed soil nutrition and how that not only affects production and persistence, but also the herbage mineral concentration of the forage and hence the animal production, the impact of increasing soil nutrition on nitrogen fixation by legumes, and the other key area of this work is we're looking at the financial risk analysis or the economic model of what are the risks and benefits of increasing soil inputs. So what are the trade-offs with costs and the benefits, which I'll talk a bit more about all of these a bit later. Lucy, next slide, please. So the project activities is quite a comprehensive project, and it falls into sort of 5 main areas, which we'll go through in a little bit of detail today, and hopefully we'll get time to cover them all. Perennial legume evaluation, nutrition or soil fertility experiment, a paddock survey to see what's happening in the real world in paddocks that have currently got legumes in them, a lot of work on nodulation and end fixation, and then the bioeconomic analysis model that I mentioned before. One activity that's not listed there, but I think has been a key project activity, is at the beginning of the project, we conducted a literature review of all past research, extension, adoption and development activities that were sort of operated in this space to really get an understanding of what the literature was already saying, so we weren't reinventing the wheel, and we could use that information to really refine our project design and methodology in the areas that we wanted to explore. That lit review has been published, and if people are interested, I can provide a reference in the chat later after the talk. Next slide, thanks, Lucy. So once again, Jeff talked about a lot of perennial temperate legume options that we have on the for the tablelands. The 4 at the top there, white clover, lucerne, strawberry clover and red clover. Jeff mentioned a bit of detail, but some other sort of emerging possibilities are Caucasian clover, although Caucasian clover is not new. There has been some developments in the breeding with some new cultivars. Tallow clover, which is a trifolium that comes out of some breeding work that has been done in Tasmania. Bird's-foot treacle, which Jeff did mention, there's some experimental lines or pre-release lines that are a step from Goldie and have had some developments in flowering and seed production. There's a Caucasian white clover cross, which is quite interest. And then I haven't got photos of some of them, but they're listed there. Sulla, Stainpoint, Allsite, sulphur clover, zigzag clover. And there's some work in New Zealand being done looking at white clover with a cross of another trifolium species, Uniflorum, which Uniflorum doesn't really have many agronomic characteristics, but it does have a good deep root system. So they're trying to improve the rooting characteristics of white clover by crossing to another trifolium species. So all of these, there's a number of options, but they all have their challenges, and they may not be adapted across the whole of the high rainfall zone. And there really hasn't been a lot of evaluation work in recent years looking at a range of legumes across a range of different environments to understand where they will grow and persist. So the first sort of exercise in this experiment is actually having a network of evaluation experiments across the state, from northern New South Wales through central New South Wales and down into southern New South Wales. And we also have a site in Victoria with the co-operator. Although we're collecting all the basic information on production, it really is the focus of this experiment, just looking at persistence across a different range of environments by different soil types. So at each site there's approximately 15 species or cultivars within species being examined. At each site there's probably a few extra ones that are more suited to those environments. These sites also give us a way of digging into that end fixation story, the nodulation and end fixation story in a bit more detail than what's going on in the paddock, because we are sowing cultivars, we know what rhizobia we're putting on, and so then we're able to then look at the nodulation and extract what rhizobial strains are actually being used to form the nodulation. So all in all, it's going to give us a better picture of a somewhat limited range of perennial options that we have, and understand where they will grow and persist in a much better way than we currently do. But we are conscious of the fact that going into the future with the predictions around climate change, there will need to be a long-term breeding program to help us to develop resilient legume options. And that is outside the scope of this project, but we have a keen interest in trying to identify some traits that need to be examined in more detail. Next slide, please, Lizzie. So just quickly, I'm not going to dwell on this. Everybody knows what the last few years have been like on the Northern Tablelands. I think Suze mentioned earlier that last year was the driest on record, which are not great years for trying to establish legume trials. But we have 3 sites on the Northern Tablelands, one at Wandsworth, which is on a sort of trapped soil, and that's between sort of Guyra and Inverell. We've got one at Glen Innes here on the research station, and that's on a basalt soil. And we have one at Guyra, just west of Guyra, which is on a granite soil. They're in various states of being sown, established and being sampled, but all 3 are functional at the moment, and we've been collecting data this year. So it's an ongoing project, so hopefully in a field day next year you'll be able to come and have along and have a bit more detail. Next slide, please, Lucy. So the soil fertility is probably the main crux of the whole experiment, and we're trying to understand how improving soil fertility management can help us improve the drought resistance or resilience of perennial legumes. And we're using white clover as our legume of choice for this study, as it still is the main white legume used on the tablelands. So there's a fair bit of literature that shows that increasing soil fertility or addressing any deficiencies in the soil can confer some drought resilience. And that happens through a few different mechanisms. One is improving the plant growth, particularly the root growth, which means the plant is better able to explore the soil volume that it's in for moisture. It also can improve infiltration and soil hydraulic properties, so you get better availability of water to plants. And then there's also internal osmotic regulation in the plant cell structures, strengthening the cells, and maybe they're able to better regulate the water flow through the leaves and stomata. The priority soil treatments identified from the literature that we did showed that lime to correct soil acidity, phosphorus, sulfur, potassium are key macro elements, and then boron and molybdenum, which seems to drop off the list there. I must have forgot to put that on. But the 2 trace elements, boron and molybdenum, are also very important. Within this experiment, we are not specifically looking at boron and molybdenum, although we do hope to explore a PhD program to look at that in more detail down the track. So we've concentrated on lime, phosphorus, sulfur and potassium because of the extent of the deficiency across the target region. They're all major problems across much of the target region. And the known literature is that shows a relationship between the nutrient and drought response in the plant. Next slide, please, Lucy. So we have a series of network of 8 experiments looking at these nutrition parameters. Once again, in the north of the state, central part of New South Wales, and down in southern New South Wales. And we're looking at white clover persistence under different soil fertility treatments in a mixed pasture sward with Phalaris. And as I said, we're looking at lime, phosphorus, sulfur and potassium, and we're looking at the additive effects of these elements. And we're doing that in a factorial way. We do have a couple of just monoculture white clover treatments in there, and we have some monoculture Phalaris treatments as well, so that we can do some comparisons. Once again, we're really looking at productivity and persistence under these soil fertility treatments, but we're also looking at the impact on mineral concentration of the forage. So if we significantly alter the potassium fertilizer, let's say, what does that do in terms of the potassium that's getting transferred to the forage, and does that put the mineral, the cation mineral concentration out of balance? And if it does that have any implications for animal production? We're also trying to get a good handle on what's happening with soil water under these treatments, and so we've put in a couple of the sites have got access tubes, so we're able to record soil moisture and soil water and have a look at the relationship between the changes in soil water and the soil fertility treatment as well. Next slide, please, Lucy. So we have two sites on the Northern Tablelands, one at Glen Innes, once again at the research station on the basalt soil, and one at Gyra on a granite soil. And at that site, it is one of the ones where we're looking at soil moisture in a bit more detail. So once again, hopefully you can come and have a look at these sites in 2021 and get a better understanding of them. Next slide, thanks, Lucy. Okay, so another activity we're doing is a white clover survey. So trying to understand what's happening with white clover production and persistence in the real world. So what's happening on farm under a range of different management strategies, environments, climates. Is there any common themes? Now, although the last few years have not been conducive to establishing field experiments, it has allowed us to tweak this survey and understand what's happening in pasture condition and pasture health in the peak of a drought, so the height of a drought situation, what's happening on the ground, as we transition through to recovery and then post-drought. So although originally the survey was only going to go for 1 year, we now extended it over a couple of different years, a couple of different seasons to try and capture what's been happening in all those situations. There's 12 sites across the Northern Tablelands, from north of Tenterfield down to south near Walker, from east over near Ebor, right on the edge of the Tablelands, and west of Uralla. And at each site we surveyed at least 5 paddocks, sometimes more. And the survey comprised of 2 sort of different components. There was a farmer questionnaire, so that we could get some really good detailed history and background of each paddock, but also the farmers' perceptions of legumes and what the main challenges for them they were experienced with legumes in general, but white clover in particular. And it was interesting, Jeff's talk, he mentioned bloat, and even in the height of drought last year, every producer wanted to tell me about the problems they had with bloat in a good year. So I think we sometimes concentrate on all the problems in a bad year, but we also need to remember that there are also challenges in a good year with any of the pasture species that we use, and bloat is consistently mentioned as something that we need to address. Then the paddock survey was looking at pasture composition, soil health, pasture health, a range of different components that it's too long to go into, but we also looked at white clover soil seed banks, which Jeff also mentioned, which I'll go through a little bit more in a minute. And it also, where there was clover present, gave us another opportunity to have a look at what's happening with modulation with white clover in the paddock. Next slide, thanks, Lucy. So as Jeff mentioned, white clover can act as an annual, particularly at subtropical latitudes. And we don't tend to think of the Northern Tablelands as subtropical, but we are actually at a subtropical latitude, and white clover often in those environments will act as an annual and regenerate a lot from seed. And I think when there's been a lot of white clover work, development and plant improvement work done through the 1980s and the 1990s, the concentration was on stolons and the vegetative radiation characteristics, and not much was looked at seed. And Jeff mentioned the seed bank study that was done in the 1980s. And to my knowledge, that's the last significant study looking at white clover seed regeneration and white clover seed banks in New South Wales, not let alone the Northern Tablelands. So through the survey, we've been coring all the paddocks and bringing them back and extracting the white clover seed. And you can see the graph with the blue, solid blue bars. You can see that just shows you sort of a bell curve of the white clover seeds extracted. So the first one is less than, or 0 basically, then 1 to 999 seeds, then 1,000 to 10,000 seeds, and then the other two are sort of greater than 10,000. And there's just a number of paddocks where we extracted that number of seeds. So I think the key point there is that we range from 0 to 47,000 seeds per metre squared. So huge variation in the amount of seeds that we extracted from those paddocks. So now we're in the process of trying to understand what factors were impacting on that difference in seed. And so the bottom graph on the right-hand side is rainfall, and you can see that there's a bit of a relationship with rainfall and the number of seeds. I'm sorry, they're really hard to look at. It was just to give you a capture of the sort of data that we're getting. And the top one's looking at pasture age and what the relationship is pasture age. But obviously there's a lot more relationships we need to pull out, particularly soil fertility and also the grazing management one. And some other questions that we're going to look at with this study is regeneration in the field. So are we actually seeing much regeneration on the paddocks where they've had huge amounts of seed? If not, why not? And also what the hard seed content is, which is probably linked. But we tend to not think about white clover as having hard seed, but actually there's a fairly large percentage of the seed that's produced is hard seed and breaks down over a long period of time. And that's another thing we probably don't know is how long that breakdown period actually is. And so all of that information hopefully can help us to show how we can try to improve recovery from seed, particularly if we're going to keep getting these sort of periodic droughts, and white clover is going to go through this boom and bust sort of situation. Next slide, please, Lucy. So the next activity is the nodulation and rhizobial work. I'm not going to be able to do it justice in the time we have allotted today. This next couple of slides is just to show you, give you a bit of a snapshot of what Jessica Rigg and her team in the group are doing, and hopefully we can have another catch up soon and maybe get Jess in to talk about what they're doing, because it's really interesting stuff. But their activity is really broken into sort of 3 sort of groups. They did an initial screen in the lab of all the sort of temperate perennial legume options we've been talking about, and using commercial strains and looking at the compatibility with the rhizobia, the formation of nodules and NPICs in a lab situation. They have taken the opportunity to using one of the evaluation sites. This is the slide on the screen now, and doing a more in-depth understanding of what's going on in the field and having a look at nodulation and nodule occupancy and efficacy. Sorry, I can't say that word. And then we're moving into another experiment now, looking in the lab, trying to understand the influence of pH and nodulation and fixation and biomass production. So that's some interesting work that they're going into. Next slide, please, Lucy. So this is just, I'm not going to go into this in great depth, but this is just some of the data that's coming out of those sorts of projects that Jess and her team are working on. And you can see there that the first thing is that there's probably not an overly huge amount of nodule scores going on there. Everything seems to be under 4, except for maybe the white clovers, which seem to be scoring a bit higher. And then you can also see within some of the cultivars that there's quite a large variation. So if you look at something like, let's say, relish, red clover, they're going from scores of just over 0.5 to something around 4.5. So there's a huge variation within some of those species. So there's some interesting information there, and as I said, unfortunately, I just haven't come to it full justice today. But there's, it really is an important part of the project, and I think it really complements some of the field work that's been going on. Next slide, please, Lucy. So the final component is actually led by Warwick. So any tricky questions, Warwick can answer these ones. And it really is a sort of work in progress at the moment. It's understanding the financial risk analysis, so understanding what the risks and the benefits are if we change some of these management situations. And basically all the information coming from the field and the survey and the nodulation work is going to funnel into this process and help to construct a model that can be used to actually then build scenarios about legume persistence under different seasonal conditions. And also to help that building of that model, there's also some glasshouse work being conducted by Mark Norton and his team down at Wagga, looking at white clover mortality and then also white clover recovery from known soil moisture limitations and also under soil fertility. And to try not to reinvent the wheel, Warwick and his team have been looking at other models, including the CSIRO model that was developed by Mike Hill in the 1990s, looking at white clover adaptation and seeing whether they can interrogate that to use that to build the model for the Ozfarm platform. So that work will sort of bring all the project elements together and hopefully make sense of everything in an economic aspect, which Jeffrey also mentioned in his talk, that we need to understand the economics of the systems that we propose to change. I think it's the last slide with the now, Lucy, yeah. So thank you for listening. I hope I've been able to whet your appetite for the Extending Boundaries Legume project. And I hope I've shown that it's a very comprehensive project with a wide range of project activities. And we will hopefully be having a field day event near you sometime in autumn in 2021. So please keep a lookout for any event flyers and come along so you can see in person what's going on at the project. So thanks, Warwick. Over to you.
Great. Thanks, Carol. That was really good presentation to highlight what's going on, the many different aspects that are going on in that legume project. Just one quick question to you, Carol. How did you know where the white clover paddocks were located for your team to do the surveys?
Okay, so it wasn't just a case of rocking up to people that we knew and having a look at their paddocks. We did actually seek people to apply, and there were a few criteria around what we wanted for paddocks. So we wanted at each site a range of paddocks that had low white clover population through to a higher white clover population, and also a range of pasture ages as well. So yeah, there were a few criteria that we needed to tick to be able to do the survey at people's places.
There's another question here, which is probably related both to either you or Jeff. It's around the role of or potential for nematodes and damage in white clover.
Yeah, so there was a bit of work done on nematodes in white clover on the Northern Tablelands in the 1990s. Mark Norton and his group did that sort of work when Mark was at Glen Innes. And to be honest, there hasn't really been much nematode work done in recent years, so we don't really know. We probably don't know the answer to that. It's a bit of an unknown and something that probably needs to be followed up.
Yep. Another question just about naturalised legumes like Ayrsford treacle and those. Can you or just briefly discuss their role in systems of non-tablelands?
Yeah, so there are a number of sort of native legume species. Glycine is probably the most abundant, and also desmodiums. They do, in certain years, form a significant contribution to a pasture, but they're a bit like a lot of legumes. They're fair weather friends, so the seasonal conditions need to be right to get the legume to be contributing largely to the pasture system. Jeff, do you want to make a comment on native legume? No, he doesn't. Yeah, so they are about, but they don't make a large contribution except in certain seasons.